Advancing monitoring networks in the Scott Valley Watershed, a collaborative successful effort. Multiple agencies maintaining monitoring networks in the Scott Valley Watershed for water management, habitat restoration, and the water allocation. These agencies coordinate and collect data such as precipitation, stream flow, groundwater levels, and water quality. While network expansion has occurred under the Sustainable Groundwater Management Act, SGMA, additional monitoring stations are planned for ET, soil moisture, and tributary inflows. Maintenance of the monitoring network is critical for establishing a historical record while the watershed works towards sustainability. All right. Dr. Foglia is a vice president assistant with projects in the areas of hydrological modeling, groundwater management assistance, and managed aquifer recharge. At LWA, she leads the groundwater service for Ukiah Basin Groundwater Sustainability Agency. The development and implementation of groundwater sustainability plans for Siskiyou County and for the South African Sub-Basin Sacramento Central Groundwater Authority. And she is designing and implementing groundwater recharge projects for the Hartnell Water District, the Scott Valley Irrigation District, and the Dunnigan Water District. Since January 2016, Dr. Foglia is also an adjacent faculty staff in the Land, Air, and Water Resources Department at the University of California, Davis, where she teaches a graduate class on groundwater models and model calibration. She also teaches groundwater modeling classes for the State Water Resources Control Board. She holds a Master in Physics from the University of Milan, Italy, and PhD in Environmental Engineering from ETH Zurich, Switzerland. Please help me in welcoming Dr. Laura Foglia.
Okay, thank you so much for the introduction. And I know that I'm feeling as a part that was supposed to be for somebody else. So I tried to come up with an idea of a different topic that I didn't present in the past, but now that we are all working in a little bit more in implementation of project and stuff with specific projects that are really concrete, it's good to understand that what's happening in Scott Valley in terms of data collection. Because I have to say, probably it's really one of the places where we have the biggest collaboration and there is a lot coming together. So I really try to put together a few maps, and this presentation is mostly to give you an idea of what's happening in the valley. So that's and then different entities are doing a lot of different things, but we are trying to get everybody on the same page and share the data, share the information. So. Yeah.
Try it again, Laura. Is it, you know what? Is it on? Where do you have it? Let me try it on the. Is it the way you have it on the?
We tried it out really fast. We're building it.
Okay, go ahead. We can get it from here. It's okay, right here. You're gonna need to, Laura, you're gonna need to ask us to push. You're gonna need to ask us.
Really? We did.
Oh, there you go. You're good. Yep.
Okay, so, just make an introduction now. What are the monitoring networks that we are talking about? We have classification, we have stream flow, groundwater, recharge, geochemistry, and water quality. And also, as usual, we have ideas of new proposed station, but we always want more. That's kind of very difficult in the work we do. There are really a number of agencies working in Scott Valley, and I think we need to remember that there is so much happening. And what we are trying to do through the groundwater sustainability plan implementation is really see if we can bring all these data in one place and make them available also to the public as much as possible. So that's kind of our goal. So we have data that comes that are coming from the geological survey, some other from Department of Resources, NOAA, Siskiyou County has some data through the Sigma process, the RCD and Scott River Watershed Council, Forts Valley, then municipal agencies, and we also have some what we call the community groundwater programs. So there are still this was mostly before the Sustainable Groundwater Management Act, when members of the Scott Valley community, they just got together and started collecting groundwater data just to get an idea of how was the groundwater moving around. Let's look at climate and stream flow monitoring. So this is a map of the entire Scott Valley watershed, and the red line that you see in the middle, that is what the Department of Water Resources defined as the Scott Valley groundwater basin. So when we talk about the Sustainable Groundwater Management Plan, is for that red wiggly area that you see there. But we cannot really look at just the groundwater basin because the contribution that comes from the entire watershed needs to be taken into account when we look at the hydrological balance. So what we have right now is all the blue circles are flow stations. So there are measurements of stream flow in the main Scott River or in the tributaries. But we know that this effort is going to be heavily advanced because Scott River Watershed Council and Forts Valley, they got a new grant for installing more stream flow gauges. So this is where we're starting from, but it is more. We also have the snow station, which are the light blue. They are mostly on the west side of the basin, as expected. And then in red is a preliminary set of precipitation station. Actually, we just installed through the water sustainability plan, we installed about 10 new precipitation stations on the eastern side, that they are not yet in the map because we installed them in October. We need to see if they survive the winter, and then they may become a real station, maybe yes, maybe not. But we put them on the eastern side because the eastern side of the valley is the one that gets less precipitation. So we wanted to kind of get a better sense of when there is a good rain, if how much is really coming down the gulches and so on. So this is for basically, as a more climate and large scale type of data. Then what we did, we put together this map. So this map, the black line again is a groundwater basin, and blues are the rivers. So we have the Scott River and most of the creeks. We put together this map for a meeting with the stakeholder board. Basically, we want to send out the message that a lot is happening in the valley, and there is a lot of effort in trying to understand this hydrological system. So we started working on this Sustainable Groundwater Management Act with Siskiyou County in 2019, and what we did with this for this presentation for the stakeholder board, we created this map. So the orange dots are the sites that were there before 2019, and then the green ones are all what we added after 2019. And the dots are mostly for groundwater level data collection. So we have continuous measurement of groundwater level and temperature. And I think it's nice, it's good to see like the numbers, because to me, for a valley like Scott Valley, it's pretty impressive. We installed 14 new wells with continuous groundwater level and temperature, 2 flow stations on the Scott River, 7 flow stations in different irrigation ditches, 18 rain stations that are the ones that are not yet in the map, because out of 18, probably some will be lost after the winter. And then we are doing a lot of geochemical and water quality sampling collection, and we have more than 14 sites for that. So this gives an idea of how much information we have on the groundwater system right now. And on top of that, we are also working with the Watershed Council up. We were working with the Watershed Council up on the tailings now. It's a different project, but the Watershed Council is collecting a lot of information in the tailings area, and we get stream flow and groundwater levels everywhere. So, you know, the tailings is a different beast, let's say, it behaves differently. So in the current hydrological model, it's not super refined, but these data are going to be, they are already being incorporated into the model, so that maybe we understand a little better what happens in the tailings and how the tailings are really impacting the rest of the groundwater system. And then for the ones that yesterday were at the tour, we have some specific data collection to demonstrate the benefit of the recharge project using the Scott Valley irrigation ditch. So to basically a little update on the Scott Valley irrigation ditch recharge project. To get going with this groundwater recharge project, we had to ask for a temporary permit to the State Water Board to be able to deliver the water in the winter time. And the only way to get these permit approved is to demonstrate that you have a really well designed that network of data, and that you are going to demonstrate the benefit of the data. So that's why we designed specific data collection, that it's really to try to demonstrate that the water that is applied on some of the fields along the SVID, it's really going to benefit the river and wildlife later in the season. So this is our goal. So we have a number of groundwater wells that are instrumented and are measuring groundwater level continuously. And we have 2 flow stations on the Scott River, and the 2 flow stations are one just above the diversion point. So basically, yes, when we stopped yesterday at Youngstown, the flow station is just there. And then there is another one which is downstream, because we need to demonstrate that the water that gets diverted into the ditch is really not impacting the largest flow that is still in the water. And then we have 5 flow stations along the ditch, because the ditch is not lined. We all know that. So there is some loss, some leakage that just happen into the groundwater because of the unlined ditch. And then we need to quantify how much water from the ditch gets applied to the different fields that are participating into the project. And we also added a new shallow well transect, which is just, you see those the transect with the 3 wells one next to the other. It's a little bit farther downstream, and those data are new. They've just been the monitoring well has just been redeveloped, and we are starting collecting the data there. And then something interesting that we started doing in 2023, but then it was very much more successful in 2024. Because of this goal of demonstrating the benefit of whatever we do, and in this specific case of recharge from irrigation ditches, we designed a sort of geochemistry plan. So what we are doing is we are using natural occurring, stable, and radioactive isotopic tracers, and we use that to help distinguish water sources. So is the water coming from, is a river, is a surface water, or is groundwater, is a mixer? If it's a mixer, out which type of mix. And then we are using specifically radon to identify gaining and losing stream leaches. So radon degasify really quickly when it gets on the surface from groundwater. So the concentration of radon tells you if that specific stretch along the river is fed by groundwater or if the river is moving. So it's not a quantity, but if you do it, so what we are doing this type of data collection along the river. So we can basically map which sections are always losing, which section are gaining, and which section maybe move around depending on the season. And we do it during the winter time, we did it every month. And in the summertime, we are doing this type of data collection every 2 weeks so that we can really see the changes. And for example, in Cedar Creek, we design, basically Cedar Creek, we want to see if the water that goes, that infiltrates through the irrigation ditch makes it back into the river later in the season. And so we designed the experiment with 3 points along Cedar Creek. So the diversion point, the green one doesn't really have a name, and then we have the orange one is called the salmon pool. And then we were measuring the same in the ditch itself. And what we wanted to see is that the irrigation ditch doesn't change composition because it's always the surface water, doesn't get any, you don't expect the irrigation ditches getting any contribution from groundwater. They're up here, so they should not get groundwater. And that was demonstrated too. The ditch does not get any groundwater contribution. But then what we wanted to see was the groundwater contribution increasing down toward the salmon pool, which means that there is more water contributed to that specific location. And I think, yeah, these are other examples. I think that there is one of the poster here is really just all on the geochemistry. Somebody wants to know more. And we did the same thing along the main Scott River, and we selected these few locations. We are now increasing the number of locations. So if we move from Youngstown is the green point, and then we move downstream. And as you see, we did it very consistently throughout the entire summer. These are the data up to October. The winter has been a little bit more challenging because you cannot do this type of data collection in rains because you just get rainwater. So, for example, we were supposed to do it this week, but it's not happening. It's just doesn't work. So if you just look at the plot, so on the y-axis, so higher is the radon concentration. So higher radon activity suggests higher contribution from groundwater to the river. So, and you see that we are moving across the time. So you see that the contribution from groundwater to the river changes between April and September. And this is pretty much what we want to see, because we know that in the winter time, the river is mostly surface water because it's raining and whatever. But in the summertime, we really want to see the radon concentration, so the groundwater contribution going up. And it's only 1 year, so we don't want to make a big conclusion out of this, but it seems to be working, and it looks like we will have another good year of data in 2025, so we will be able to put together 2 consistent years of data. And then we are also doing some water quality. The water quality is needed because of the recharge project. We can demonstrate that it's not impacting the quality of the water underneath. And also because of the groundwater sustainability plan, it has a water quality component. And we started with a network that was very small for the groundwater sustainability plan, but now we are expanding. So we are using data from municipal well and domestic wells. We have data from Scott Valley Watershed, and then we are adding new data about the sustainability planning implementation. And then last one, We were also around this week and last month. So we are working with different landowners to figure out a way to basically better understand, let's say, the water budget in the valley and better understand how water is used and if there is a way to be more efficient. And our goal is really to see if we can install the rapid transpiration station and soil moisture sensor throughout the valley in different type of crops, different type of irrigation, different type of soils. So we can better understand who can eventually be more efficient, so save water, or when it's best to use maybe some conductive project, use some surface water late early in the season, and to avoid too much groundwater pumping. So the idea is really it's to install about it's going to be about 10 stations throughout the valley for 3 years. It will be a 3 years experiment, and it will probably happen next month, March, because we need it before the irrigation season. So we are really going around. We will have yesterday and today looking for specific location. And then we will compare with satellite data. There was a lot of discussion around how good or bad the satellite, like OpenET, can be in the valley. And we really want to ground truth. Data that are collected on the ground will be way more well received by everybody. So if we can use the data collected on the ground to refine these big open source tools, that would give everybody a little bit more confidence on those data. And then it will also help us assessing potential efficiency improvement. And all this information together with a big project that Shana and Sarah from Scott Valley are working on tributary inflows, all this information will go into our Scott Valley integrated hydrological model. So it will refine the water budget and it will help us doing making future scenarios. And that's it. Yeah, quite good. I don't know if we have time.
There's time.
Yeah.
What? Thank you.
On the slide where you showed all the.
You're writing. Maybe already.
Now, are they existing now, your master wells that you're retrofitting with monitoring equipment, or you actually drilling them?
No, we drilled a few very shallow transits, just for specific location where we want something. But the ones that we did were just monitoring, very, small. Most of the wells that we have right now are existing wells that maybe are not used anymore or domestic, and we just, to the instruments.
Okay, well, what I was getting at was that, because a lot of them are just close together. And so those are likely domestic wells or something like having monitoring stuff or.
Yeah, some of these new transits are very, very shallow. They are close to the river because we really want to see, it's in the areas where we want to see for the groundwater is really contributing to the river.
Thank you, Mark.
Michael?
Thank you, Mark. Just assuming that the radon you're talking about is in the groundwater and then it gets put into the stream water and you impact it. But how are you introducing the isotopes?
It's all naturally.
No, I mean, the radon's natural, but aren't you introducing some
No,
other isotopes?
Everything is naturally.
Oh, it's only the
Yeah.
radon.
Yeah.
Okay, I thought you were doing some others.
No, there are other isotopes, but those ones are all naturally occurring, so we don't introduce anything. And I think that we presented that we are in the last advisory committee meeting, we also have some stable isotopes. And the stable isotopes, we do them in the groundwater wells, for example. We don't do radon in the groundwater wells because groundwater is just and that tells us if that specific groundwater well is getting a lot of contribution from recharge or from surface water or not. So, but and those are oxygen and deuterium, so they are, naturally we don't increase anything.
Last question.
You did a research, an experiment with recharge, to see how it affected stream flow, and I was wondering if you would, this report, what you found.
So we have some preliminary results that we are planning to present progress on the advisory committee meeting in May, just because for the one next week, it's pretty cool. We from the groundwater level observation, we saw that the groundwater level stayed way more sustained throughout the year. It was not like August and September. So we compared the data collected for 2022, 2023, 2024, and we can really see that 2024 stayed higher for a way longer time. So, and now we are trying to, we are doing the same using the model, just to see if the model is telling us the same story, so that the numbers were higher for a longer time in 2024. And then, you know, we cannot say that it's all because of the charge. For sure, it's also because of the winter and whatever. But as we always say, we need legal contribution from different sources, and they all come together and maybe help us understand a little bit better how the system evolves throughout the year.
Yeah, but the finding on the impact on the river.
Yeah.
You know, you mentioned that, what we found is that it didn't augment flows in the fall, in the late summer and fall. It augmented flows in the early summer when during the early summer, flows were added.
So the radar was saying that it's augmenting the flow in September. So we didn't just do we don't know if it's the region, but there was way more contribution from groundwater into the river in August, September in 2024. And that's why we want to do it for 2025, because if in 2025 now, recharge is happening right now. If we see the same type of contribution, then we have 2 years where we can say September, August, September is contributing.
I think what he's getting at is, you're calling it contribution, I think you're looking at it as dilution, right? That it's just a greater percentage of that same liter. It's not necessarily more water in the river, just a greater concentration on the groundwater in that liter taken from the river.
Well, that's not aware of that.
No, I think I understand. I think I understand. And it's really. I cannot put a number behind how much is contributing, but the signs, the data are telling us that the contribution from the groundwater is not everywhere.
Yeah.
And next year, with 2 years of illegal data collection, because after it's the same way for 2 years, maybe we can make some bigger money. Thank you.
I'm going into our question and answer. There's 2 mics. Let's just take the time. We have some people that are online, and it's really difficult when we're not talking into the mic for them to hear, and those people in the back of the room. So it's really good to have an exchange, but it's really valuable if we all can hear. So let's just take a little time and use the mics.
All right, thank you so much for joining.